Question 6 then asks us to find the deceleration of this suitcase, round suitcase, but never mind. This suitcase is travelling down this ramp, and then it wants to find the coefficient of friction, so to find mu. So I've sort of got two diagrams in one here. This is my first bit. This is what I'm going to use to do part A. I know that my suitcase moves a distance of 5 meters, and I know what the final and the initial velocities are, so I can work out what the acceleration is. And then this is my second diagram that I'm going to come on to use for part B. And again, I've just done exactly the same as you normally would. I've marked in my weight component, my normal contact force, and because it's a rough plane and this is moving down, friction is going up the plane. And then I need to resolve my weight into two components. So if this is 20, this angle here is 20 as well, so this component is adjacent to it. So this is 10g cos 20, which means this one must be 10g sine 20. Sorry, it's not a t there, that's a 10. 10g sine 20. And then I can start doing part B. So for part A, I should say. So I need to consider what happens on the journey from A to B. So I know that my initial velocity is 10. I know that my final velocity is 8 because that's what I'm told in the question. I know that the distance travelled is 5 meters, and I want to find acceleration. Yeah. So I'm going to use v squared equals u squared plus 2as. So 8 8s are 64, 10 10s are 100, plus 2 times 5 times s. So 2 times 5 times s, I beg your pardon, that should be 2 times 5 times a. And if we then subtract 100 off both sides and divide by 10, a comes out to be minus 3.6 meters per second squared. Now this is my acceleration. The question says to find the deceleration. Now deceleration in this case would be plus 3.6 meters per second squared. Yeah, so a negative acceleration but a positive deceleration. Okay, so for part B we need to use Newton's law of motion, F equals ma. And because this suitcase is moving down the ramp, then 10g sine 20 is our biggest force. So my resultant force is 10g sine 20 minus my frictional force. And this is equal to the mass of the suitcase, which is 10, multiplied by the acceleration, which we've just worked out as minus 3.6 meters per second squared. So my frictional force is going to be equal to 10g sine 20 plus 10 times 3.6 is 36. So my frictional force comes out to be 69.518. And then to find the coefficient of friction, if we resolve our forces perpendicular to the plane, n going up is equal to 10g cos 20 coming down, and 10g cos 20 is 92.09. And we then need to use F equals mu n, so mu is going to be friction, 69.518, divided by n, which is 92.09, and put that in your calculator, mu comes out to be 0.755. And lastly, part C. If this suitcase reaches the end of the ramp, we need to know what happens for this part of the journey. So at the start, u is equal to 10. If we wanted to just reach the end of the ramp, then v must be 0. We don't know how long the ramp is, that's what we're trying to work out, so we need to figure out s, and we know that the acceleration is minus 3.6. So using v squared equals u squared plus 2as, 0 is equal to 100 plus 2 times minus 3.6 times s. So S is going to be 100 divided by 2 lots of 3.6. So S is going to be 13.8 recurring. So S is 13.9 meters to 3 significant figures.